Okay, again, this is a brief review. For more details, you're going to want to use your book as well as the skill practice from Unit 1, because many of the skill practice things you didn't do in Unit 1, as well as the skill practice in Unit 2, because you were supposed to do them, but many of you still didn't do the skill practice in Unit 2, so it all contains material which you can do in practice. There are videos for Unit 2 on, so Unit 2 has videos, Unit 3 has videos, and Unit 6 has videos. Thank you. End of class, or end of the day. All right. Okay, so Unit 1, you must know the 3 F's. What were they called? Does anybody remember what they were called? They're called the 5 family functions. Okay, 5 family functions, which were what? Can anybody tell me any of them? Quadratic. It's actually called linear absolute. Linear piecewise. Exponential. Last one. We have linear absolute value. The one we've been working on for chapter 2, 3, and 6. Linear. No, linear absolute value, linear piecewise, and just linear. Linear is where you have just one equation. Linear piecewise is when you have more than one. Linear absolute is where you have more than one. How many of those are curved?
2.
You're right. The ones that don't have the word linear, right? Understanding what they look like, what controls them, meaning what makes them positive and negative. Hopefully you know quadratic is wherever you have x to the second power. That's called quadratic. Linear absolute value is that the x is in the absolute value sign. Linear piecewise is that you have more than one linear problem. Linear problems were y equals mx plus b. That's what we've been doing for the last 4 months, is linear equations. Of course, we've had 2 forms. We've had linear, and then we've had ax plus by equals c. Those are the 2 forms of linear equations we've dealt with. All right. This being the key one. Exponential is where you have a variable in the exponent. Can anybody tell me how I know whether these are increasing or decreasing? The negative in front of the x. For all of them except which one? No. What? Absolute value. Where will the negative sign be? It has to be outside of the absolute value signs. So the negative would need to be out here. Okay, so it could be a -1 like it is there. It could be -3. It could be -5. But remember, it has to be multiplied. It has to be right next to the absolute value sign. And that tells you whether the absolute value is increasing or decreasing. Okay. Your quadratic, whether it's increasing or decreasing. Your exponential, whether it's increasing or decreasing. And then, of course, your linear equation, whether it's increasing or decreasing. How many of those have minimums and maximums? Which ones? Right. So those are the types of questions you can expect to see. Those are the types of graphing questions. The entire test is multiple choice, which has a tendency of making it more difficult, because if you don't know the key things you're looking for, you will have a tendency of trying to pick an answer that looks absolutely nothing like the rest of the answers. And that would be the wrong thing to do. If there's an answer and it's completely different than all the rest of the answers, chances are that's the wrong one. Okay. Usually there's going to be 2 to 3 answers that'll look similar for a reason, because there's a key concept. So when you're looking at these, a lot of times it's understanding whether it's supposed to be increasing or decreasing, the shape of which it is, and that will help you determine whether or not which function family it is. Now remember, there's a lot more information that went into this. This is what we did for the entire first 6 weeks. Well, actually, for the first 6 weeks. And then we went into chapter or unit 2. So I have notes that are on Portal about this. There are no videos about this because this was all vocabulary. Many of you did decent on this part. It was the next part that was a little bit more difficult. Unit 2 was all about linear equations and linear inequalities. Equations and inequalities. Okay, so Unit 2 was nothing more than solving equations and solving of inequalities, graphing of equations, and graphing of inequalities. That was all done in Unit 2. Okay, so you had things like this, 3x plus 10 equals 50, and you had to solve. Okay, we minus 50 from both sides, and you divided by 3. Okay. Then you had inequalities. What makes an inequality different than solving an equality? No, that's not what makes it different. There's one rule that's different. Not visually different. There is one mathematical rule that you have to apply to inequalities that you do not have to use for equalities. When? Right. If you multiply or divide by a negative, which means if this number in front of x is negative, then you have to flip the inequality. Correct. All the rest of the math is the same. I would minus 10, I would divide by negative 3. But because I'm dividing by negative 3, I have to flip the inequality. That is the only difference in solving of this problem and this problem, other than the numbers, of course. But the only difference in solving is the fact that if you were to multiply or divide by a negative, you flip the inequality. Now you could do that for this one too, but would it make a difference? When you flip an equal sign, what does it become? An equal sign. Yeah, it stays the same. So well, that's why we don't mention it with equalities. Because if you were to flip an equal sign, it stays the same. It's not like it changes. Whereas inequalities, it goes from greater than to less than and from less than to greater than. All right, so that was the big difference in problem solving. Graphing. You have to understand where the y-intercept is. Okay. Can anybody give me the y-intercept for this first problem? 10. So y-intercept for the second problem? It's also 10, right. So when it's in y equals mx plus b, the number that's there by itself is the y-intercept. That tells me where my line will start, correct. And then knowing whether it's a positive slope or negative slope. Remember, you're doing a multiple choice test, which means on a graph, you're going to have to know what the y-intercept is, and you're going to have to know whether it's increasing or decreasing from that point. And then 9 times out of 10, you'll be able to find the right answer, because there will only be one that actually does both, that starts at the correct point and goes in the correct direction. Okay, so I'll repeat those again so that you can get them down. Is that you want to be able to first know where the y-intercept is, and second, tell whether the line is increasing or decreasing. All right, so there's a couple ways we find the y-intercept. In this problem, the y-intercept is where it is, but if we had a standard form problem where you had 3x plus 2y equals 300, how do we find the y-intercept? I plug a 0 in for x, correct. Plug a 0 in for x, and you'll find the y-intercept. Put a 0 in for y, and you'll find the x-intercept. That will work in this as well, so that you can find your equation of a line, or you can see where the line is supposed to be drawn. Right? That works in either problem. Okay, so what are some other things that we learned about inequalities? Well, we learned how to graph. If it was on a number line, We knew we had open dots and closed dots. What's the difference between an open dot and a closed dot? What does a closed dot mean? Means equal to. Whenever you say the word equal to, that means you have a closed dot. And whenever you see a closed dot, you're supposed to say the word equal to. The greater than or less than depends on which way the arrow goes. What's greater than? Which way am I shading, or which way will the line go? To the right. Greater than is over here. Less than is always to the left. And you have to be careful because sometimes they write the variable on the opposite side. So you read it backwards. X is greater than 10. You read it backwards. Or you can flip everything and put it like this because they are the same. X is greater than 10, which means X is greater than 10. So this would be 10. X has to be over here. All right, so you had the graphing of an inequality. We had and and or problems. What was an and problem? It was called an intersection. What was an or problem? It was called a union, correct. A union means all those answers are possible. That means you could have this or that. Like it could be greater than 10 or less than -2. But an and problem is where they did what? Overlapped, correct. We were looking for where they overlapped. Now, can some or problems overlap? Yes, they can. So, for example, if you had all the numbers greater than 3 and all the numbers greater than 5, they're overlapping at everything greater than 5. So that's your answer. Because this is where they overlap from this point on. There's where 2 lines are. Right? So that was used in 2 as well. And then your intersection problems usually look like this because you're looking for the answer that was in between those 2 things. Just like when you were working backwards in linear equations, when you were working backwards, you dealt with absolute value problems. How do you reverse absolute value problems? Correct. You get your problem down so that the only thing left is the inequality and an answer. So that means if there were things outside of the inequality, you have to get rid of them first. So say I had a 3 over here, which means multiply this by 3, and I had +2 over here. Okay, and there's an x in the middle here. What I want to do is I will subtract 2 to get rid of it, then divide the problem by 3 to get rid of it, and then whatever's left, split it into 2 problems. So whatever's left in here would be one problem here and one problem here. The exact same problem, but the answers would be opposites. So for example, if I put this was equal to 11, the first thing I do would be -2. So then that would change that 11 to 9. Then I divide by 3, which would change that 9 to 3 because 9 divided by 3 is 3. And then whatever was in the absolute value signs, you'd write it twice, and it would be equal to 3, and the second problem would be equal to -3. That is how you get rid of absolute value signs. You have to split it into 2 problems, make one of them positive and one of them negative. Answers. And then, of course, you should know that your absolute value is going to look like this. Unless the sign in front of here is negative, then it would look like this. All right, again, remember this is just very basic, very vague, very quick. We don't have a whole lot of time today, so there are videos for each one of these sections that you probably should review and watch so that you can do well on the exam. Remember, the exam is linear equations based, 1, 2, 3, and 6. So we look at Unit 3. And Unit 3 had to deal with being able to transform an equation to y equals mx plus b, or transform the equation to ax plus by equals c. So So that means moving something to solve for y. And you have to be careful because when they ask you to solve for something, it's the same as putting it in this form. If they ask me to solve for y, that means everything moves except, if I solve for h, everything moves except, if I say solve for p, everything moves but, right. So understanding that solving for y and put into slope-intercept form are the same. Okay, they mean do the same thing. What are the two rules for standard form?
The leading coefficient can't be a negative.
Excellent. That is 100% accurate. The leading coefficient cannot be negative, or
No fractions or decimals.
no fractions or decimals. Excellent. Okay? So understanding that the leading coefficient is the coefficient in front of x, because x is at the beginning, that's what leading coefficient is. Coefficient is the number in front of the variables. Okay? So the leading coefficient cannot be negative, and you cannot have fractions or decimals anywhere. You can have negatives other places other than here, but you can't have fractions or decimals. Now, what makes this unique in Unit 6? Do we need to put it in standard form for Unit 6? No, we do not, because we're looking for things that are what in Unit 6? What are we looking for in Unit 6? Opposites, right. In Unit 6, we were at times looking for opposites. So if we had a negative x, if we had a positive x, we already have the beginning of opposites because we're using elimination or substitution. But in Unit 3, it was just being able to transfer it from this to this and this to this. So a couple rules we learned was how to get rid of a fraction. How do we get rid of a fraction? We multiply the whole problem by the denominator. What if the denominators are different?
Find a common denominator.
Right, you multiply by a common denominator, which means is it going to be a bigger number or a smaller number? It's going to be a bigger number. Okay. How do I get rid of decimals? That's the easier of the two. You multiply by the number of place values, right? So if you only want to move the decimal one place, you'd multiply by 10. But if you have to move it two places, you multiply by 100, right? And if you have to move it three places, you multiply by, okay? And whatever you do to one part of the problem, you have to do it to the entire, right? When you multiply by the denominator, if it happens to be the same, so for example, if it's x over 4, I'd multiply the whole problem by 4. What happens when I multiply and divide by the same number? No, they cancel out. And I'm left with just what's on top, which would be, right. So this is one of the skills that you learned in transforming equations. How to solve for y, how to put it in slope-intercept form, which is the same, how to put it into standard form, which means no fractions, and the leading coefficient can't be negative. Now, the understood rule that we don't really talk about is that what have to be on the same side? X and y have to be on the same side, right? But that's the visual part of it. Like, do I have x before y? That's the visual part. I look at it, oh, visual. Just like here, y equals. If I have y equals, it's the visual part. I can't have anything in front of y. It's just y equals. What's the understood number that's always in front of y? 1. Okay. Do I have to write it? No. All right, so then also dealing with literal equations, we had to solve like area equals 1/2 base times height. And when we solve for height, that means height didn't move. How do I get rid of 1/2? I multiply the whole problem by 2, so it becomes 2a equals bh. And then how do I get, which one do I need to move? B or h? B. So I divide by b, and that's the answer for what h is. Okay. Literal equations, being able to work forwards and or backwards. That was the functional key for Unit 3. Did we do some other things? Yes, we did, but for the most part, it was understanding how to graph, understanding how to manipulate or transform this equation to this one and this equation to this one. All right? Why did we learn that? Because in Unit 6, which is the last unit, we learned to solve for more than one variable. In Unit 6, we learned about substitution. And we learned about elimination. Okay. So in elimination, I think it's only one L. I can't spell. Sorry, guys. Is it one L? Yeah. In elimination, the object is to try to get one variable canceled out. All right. So when we eliminate something, we're looking for opposites. And in substitution, we're trying to get them in both what form? No. Slope-intercept. We get in y equals mx plus b form. Then we can put them equal to each other, these two pieces. Solve for x. In both of these problems, what do you always have to do? Starts with a P. Glade. Plug it in. Yeah, you got to remember that when you get one answer, you have to turn around and plug it back in and find a second. There's always an X and a Y answer. Sometimes they're not. What happens if the answer you get makes no sense whatsoever? That means they don't what? They don't intersect, which means they're parallel, right? Which means there is no answer, right? When you don't get an answer, it's really goofy, and you're like, okay, wait. What happens if the answer ends up being the same, like 0 equals 0, or 10 equals 10, or 30 equals 30? They're touching all over because they're the exact same line. They're the exact same line. They're one line on top of each other. So substitution, we dealt with getting two equations that look like this. So y equals 3x plus 7, y equals 4x minus 2. And in this case, we would go ahead and, because they're both in y equals mx plus b form, the quickest way to solve this is to put 3x plus 7 equal to 4x minus 2. Why? Because they're both equal to y. So that means now I can put them equal to each other. This is quicker. Can you use elimination if you want? Yeah, you can. But you'd have to get the y and the x on the same side first. So this would be negative 3x plus y equals 7. This would be negative 4x plus y equals negative 2. And then you'd have to eliminate. So that means you'd have to find opposites. Hopefully you know you'd probably either make the top one or the bottom one opposite for y by changing all the signs. So this would be positive 4x, negative y, and positive 2. Or you could do it to the top. Positive 3x minus y plus 7, or minus 7. You got to change all the signs. And then you add straight down. That eliminates one of them. Plug it back in. Solve for the other. Does it matter which way you solve? No, you're going to get the exact same answer, right? Whichever way you feel more comfortable. If you feel more comfortable taking it and always changing it to this first and then eliminating, you can. If it's already set up like this, my suggestion would be just to substitute it, solve, then turn around, plug it back in, and solve. Get an X, get an Y, there's your answer. If it's set up in elimination, then look for opposites. Hopefully you know you have the same number here, they're just not opposite. Sometimes you're going to have opposite signs, but not the same number. Sometimes you'll change one problem, sometimes you'll change both. So for example, if I wasn't looking at this, does 3 go into 4? No. So in order for me to find a number they both go into, it would be 12. So I'd have to multiply the top by 4 and the bottom by negative 3 because I need this to be positive here. Or I can multiply the top by negative 4 and the bottom by positive 3. However you want to do it. I tell people to use the same pattern. That means whenever you have to change a sign, I would always do it to the problem on the bottom. That will keep your work organized. Organization is the key to this one. All right? Okay, I wish you luck. Watch the videos. Have a good day. And we will see you tomorrow. No, we will not see you tomorrow. We'll see you Wednesday. Oh, let me explain something to all of you again. There are many of you that are floating really close to the next grade. The only way you can improve your grade is if you actually work on Carnegie. I'm giving bonus for Carnegie. I'm giving you an extra quiz if you wanted to try and work on Carnegie this week. I give you a quiz bonus. For some of you, you have two options. You can do the algebra review and or the actual Carnegie review. I'm giving you extra credit for either one. And it's not really extra credit. I'm just adding the grade.
Oh, so it's not going to count if you don't do it?
Correct.
Okay.
It is only going to add another quiz grade to your thing.